Today we are going to talk about an example of transformations. Here is the definition of half-L. The language half-L contains strings that are exactly half of strings accepted in the language L. For example, let's say that the language L contains the following strings: AAAA, ABAB, ABC. Then half-L contains these strings, AA and AB. We can draw an NFA of L like this. Because we know what strings are in L, we can also easily construct an NFA of half L. But what if the language L is arbitrary? Let's say we have an arbitrary language L. We don't know what strings are inside the language L. L is represented by the NFA M. Our goal is to create a new NFA that is based on M, that accepts half L. And turns out we can construct a new NFA using transformations. So how do we approach this problem? Let's try with our example half-L. Here's our strategy. When we receive an input string and we want to know if it is in half-L, then we can try to run it twice on M, the NFA for L. Once from the start and once from the middle point. Note that we need to run these simulations simultaneously, otherwise we will run out of input by the time we get to the middle point. So we need to create an NFA M' based on M that runs our input string and keeps track of two current states of the NFA at the same time. We can do this by having M' predict which state M will be in after it has processed W. M' then processes its received W on two copies of M, one starting at the start of M and one starting at the guess state. If M''s guess is correct, then M' will be at an accepting state of M when it finishes processing W. Let's write down our strategy so far. First, have our NFA guess the state the original NFA is in after it has processed our half-word input. We can do this by having our NFA guess every state in the original NFA by creating a new start state, S'. If the half-word is valid, we are guaranteed to have one guess that is correct. It's okay if the other guesses are incorrect. Now we need to keep track of three things: the guess state, the current state of the original NFA simulation, and the current state of the simulation starting from the halfway state. To do this, we can create n copies of the original NFA, n equal to the amount of states in the original NFA. Next, we can create epsilon transitions from S' to different states in each copy of the original NFA. We have now guessed every state in the NFA at the midway point. Then, simultaneously for each guessed state, this NFA will simulate the input string starting from the guessed state, but we also need to keep track of the input string from the original starting state. We need to create n copies of this whole thing. Now, the NFA will also run the simulation from the original starting state. Now, if the simulation from the original starting state ends at the guess state, then we have correctly guessed the halfway state. And if the simulation from the halfway state ends at an accepting state, then the input is accepted by half-L. We will need to keep track of the current states at once and the guessed halfway state. The accepting states of our new NFA should be states where the simulation from the original starting state ends at the guessed state. We also need the simulation from the halfway state to end at an accepting state. We can write this as follows. For the simulation from the original starting state, we should start at S'. And for the simulation from the halfway state, we should start at the halfway state. Therefore, the starting state of our NFA should be as follows, and the transitions should be as follows. Here's how this looks with our previous example.